There's our calendar. So that whole thing I just did right there is hiding here. Oh, did I talk about that Warren Buffett article? Did I say anything about that? No. So I just did a video on this. It's like a cool video. How many people know Warren Buffett? Raise your hand. Oh, he's up. All right. Great article on habits. And actually, when you're younger, that's the best time you change your habits if they're bad. Because once you get older, like me, those habits are ingrained and I ain't changing. All right. All right. But as you're young, and really what he talks about is the habits of investing. And that's what I was trying to impart upon you, the habits of investing early and as soon as possible so you can participate in that exponential growth and become a millionaire with ease. With actually, it's very mathematical and can happen no problem. But you got to be stick to it. I was trying to think of a word that means stick to it and understand what the end game is. All right, now let's do our actual math. Yay! This will really put people to sleep. Is everyone okay? It's like there is a class in here. Did something happen today? Nothing. No one was responding to me last hour at all. Is everything all right? You okay? Wow, you just stared at me like, okay. Well, let's move on and talk about these specific questions here. Math, math, math. Got a couple different things going on here. Is this exponential? Does it look like this has a common ratio from here to here, from here to here, from here to here? Is it linear? Does it have a common difference? Just look at the end. No, things are taken off. All right. So what's going on here? This is a weird, very specific, very particular kind of situation. And it is exponential, except it has an up down shift. So how could I find out this is exponential? I don't know how you were supposed to be able to find this out through guess and check or whatever. But if I add 5 to all of these y values, 1 plus 5, 7 plus 5, 19, you get it. Now, does that have a ratio? Yes or no? What is that common ratio? 2. But how did I know it was plus 5? Guessing and checking? I think that's not really a good way of doing it. Here's how what really happens, and this is kind of strange. Watch. Look at the first level of doing a common difference. So the first thing I'm going to do is find a common difference, a common D, or the difference because it isn't common. So I accidentally put that on our notes. 3, 6, right? 12, and then 24. That's how far those are away. Now, after that, getting the differences in the first order, I should have said first order differences. Is there a common ratio on those differences? Yes. So there's first order differences. The first order differences have a common R. And that common R is what? What is it? 2. Okay, so I can use this information to find that equation. So I want you to be very, very careful in understanding this. This is a very specific, particular kind of thing we can do when I have an exponential but with a plus k in it. And you have to be told this is a table of values for the exponential function a times b raised to the x plus k. And since it's that specific thing, then this is what I can do to find the equation. And I'm only going to do this first one. I'm not going to do both. Number one, find your find your first order differences. Okay, what is it from 2 to 10? Answer the question so you wake up. 8. Good. And so they think there are humans in here. Common difference from 10 to 34. And then what do you think this is going to be? 72 is correct because that's also, all right. And then this is, I think someone told me 216 last hour. 714, 21. Yeah. Okay. So there's the first order difference. So then of those first order differences, what's the common ratio? What is it? 3 all the way across. So guess what? That is your R or your B. Remember, it's in this format. F of X equals A times B raised to the X plus K. But now I have my B value. So again, this only works for this specific only scenario, all right? When I have an exponential with a plus minus value. and then input say it. So what I'm going to do next is create two equations to find my A and my K. The first one is y equals 2 when x equals 0. Uh-oh. What's this? Hi. Is it for me? Can I leave? Rodriguez. Oh, Ferris. Sorry. That's the staff member. Ferris, come on up here. Oh, Ferris, you made the video. All right. And then input say it. I got to create an why? Because how many variables do I have? How many variables are unknowns? 2. So 2 variables, 2 equations, and then solve the system. And I do want to pick ones that are easy. What am I doing? What am I doing? See, the past, and then I get all like discombobulated. I can only handle one thing at a time. I do have ADD. I think we all have a form of it. All right? No doubt about it. Anyway. All right. So, okay, I'll write this a little bit cleaned up. What's 3 to the 0? 1. Right? What's 3 to the first? 3. Okay, but you know what I'm going to do? I love elimination. So I'm going to solve this system through elimination. So I'm going to snap this sucker underneath this. 3 to the first is 3a, and then plus k. And then you know what? I'm going to go ahead and multiply that top by a negative. Just wanted to see that in a different color. So you see that a new thing happened there. Because I think it's faster. Faster is always better. Math works for that, by the way. Math does want efficiency. I don't want to get into it any further. I just feel like sometimes our department does not work efficiently. I don't think that's right. We should work for the fastest method. All right. And now, how do I get K? I plug it in. You know what? This is ready, and I can handle math. So I'm going to plug in this 4 here, and then find K. That's 12. So then I'll subtract 12 from both sides and get K to be -2. Okay, so K equals -2. I'll write that officially. Be a good little teacher. And then input. Why does it keep saying that? Input. I'm going to check my equation. So what's the equation? F of x equals A, 4, times B, 3. Because this seems weird. Does this really work? I don't know. Raised to the x, and then -2. Okay, and then I could check the first coordinate. Plug in 0. 3 to the 0 is 1. 1 times 4 is 4. 4 minus 2 is 2. I feel pretty good. 3 to the first is 3. Okay, good, for emphatic reasons. All right, okay, stop doing that. All right, 3 to the first is 3. 3 times 4 is 12. 12 minus 2 is 10. And then if you wanted, you could keep going, check 4. That'd be a real, if that works, we got to be good. 3 to the fourth, I know, is 81. I'm sure 4 times 81, I don't know, is 322. Minus 2 is 322. 4 times 81 is 324, so it works. So it's the same thing with this one. I'll just do a couple steps on this one. 5. Oh, come on. 10. What do you think this is? 20. What do you think this is then? 40. So the first common difference, and then the ratio after that common difference is 2. So you already have your R, and then you go through this process again. All right? Is that good enough? All right, because then we can move on to other stuff. It's going to be a lot of blabbering here. All right, exponential regressions next. I think I do this a couple times, so I will start the calculator brand new. I will move my head here. I will take this here so you know I'm up at the board, but then I'll move this because it's in the way of the calculator. Okay, I just like to know that we are in the classroom. Okay, so what do we hit first when we're doing regressions? What do we hit? Which button? No one remembers? We actually did this before. Somewhere in the middle here. Which one do I hit, everyone? This is fun. I'll just stare. I'll just sit here like this. Anyone? What? I think they're saying stat. What? Stop yelling at me. Oh, okay. You scared me. Someone actually proved they actually have a voice. It's amazing. You hit stat, then what? Edit. I feel like this is a Twilight Zone episode. Is everyone all right? And then what if I already have a list here? Well, I cry and go in a corner and shut down. No, you hit what? Clear or delete? Clear. Now we're talking. All right, and then come over here. Very strange, clear, enter. And then you go ahead and type in these values. 1, so I want to make sure 2, 3, 4, 5. And then move over 12. Now, why am I doing this? It says it's exponential, and it says to do a regression. So it's not the last question. You don't be a robot. You read, and you do what they ask. So it's not that specific, weird plus K thing that only works in that specific kind of question. All right, then what do I hit? It says exponential regression, so I hit stat, and then what do? I get a drink of water, crinkle, crinkle. Calc. And then what kind of regressions? Did we do these? We did linear, we did quadratic, we did cubic, we did quartic. There's another linear. X reg. All right, and then what do I hit right here? I'm going to wait till someone says it. I don't know anything. Teach me. What do I hit next is so I can store this in Y1? Not second? I thought you didn't know. What? Alpha who? No one remembers this? Or are we just sitting here awkwardly? We've done this before. Alpha what? Someone whispered. Trace. What if you have an 83? I don't know if someone has the 83. I love these. Where's this whole group? No one has a calculator out. What are we doing over here? All right. Vars, Y vars, function, Y1. That's 4 button clicks. Ugh. All right. So that other way is better. All right. Enter, enter, and then calculate. Okay. Remember the R squared value? That just tells me if this was 1, the points for the chart would be right on it. This is pretty good. This means it's a good little situation there. All right, y equals. All right, and then I'll tell you how we use the calculator in order to do this. All right, I'm not writing any of this down. This is all calculator. You'd have to write these answers down. Please read round to 3 decimal places. Okay, 4.9395, that would be 0.940. Some people do that wrong, and I take half points off on their test for not rounding correctly. All right, because they will on the AP exam. Bam. How much money will Mr. Kelly and Mr. Sullivan owe Mr. Sullivan in year 7? Watch this. I think this has happened before, but I want to make sure you know this. Usually what happened, and this is my window okay. Let me check this window. It seems a little steep. Yeah, I guess it's all right. Actually, I could have went a little further because this Y value is up to 267. So we'll say like 500. I'm going to have to change that here coming up. And then we'll leave that other stuff there. But watch this. My X's. I got to make sure my window has this. So I went from -10 to 30. I don't think I need that. I think that's for a later one. We'll say like 12 or something like that. That's why the graph is skewed a little bit. But watch this. Graph, if I hit second calc value, that's one way of input, say it. But then I found something else through the flip math people. Just hit trace, do this, trace, and then 7, enter. I didn't know this existed. This makes this function useless. You don't need the value function anymore. So when I'm in the graph, if you just hit trace and then force an input value and press enter, it does it as well. One other way of doing this, by the way, this only works too, is if your window has 7 in the X's. If 7 isn't in there, if you went from -10 to 5, you wouldn't be able to do this. One other way to do this that I found out from the other people is the flip math people. F of 7. That's what that is. That one, that doesn't matter what the window is. That always works. I can do F of 1,000. I can do Y sub 1 of 1,000, even if the window isn't all the way out to that. So they want to show all of that as well. And then when he loses every year from now on and refuses to pay, in what year will he be owed $5,000? Okay. Well, that's the window, and that's why I knew this wasn't enough. I want to make this 6,000 because that is when the Y value's at 6,000. That's what he's going to owe. And then I have to go here and type in 5,000. So I want to know when that is going to happen. It's going to happen at that intersection point. Second, calculate 5, intersect, enter, enter, enter. There's the intersection point. It will happen at year 8.75. So somewhere towards the end of year 8, which would actually be in the middle of 2008. This read as year 2000 as year 0. This is 2001, 2002. So it would have been in 2008, like in the fall. Okay, so that's one. Here's a second one. Do it again or not. But this is kind of true about caffeine. I think it's a little slow, though. I think caffeine leaves your system a little bit faster. All right. So I'm going to do it again. No problems here, I hope. Stat edit, leave you alone. If you don't want to do it, fine. But just going to be the teacher here and make sure. Oh, I didn't press enter. So clear, enter. Made a little boo-boo there. Clear, enter again. And then you feel free to play along as well. 1, enter, or not. 3, 8, 12. What time is it, by the way? 40. 40? 44. 44? What time do we get out of here? Is this an increasing or decreasing scenario? Decreasing. Of course, this is what happens. You get the caffeine in your system, then it slowly dissipates. Is a good word. It goes away. Decays, I guess. All right, stats. Calculate. I guess I could just put 0. Yep. Since I knew it was 0, that's X reg. And then same thing. Hey, let's do it the old way. Stat. No, wrong, you fool. I got to do it all over again. Stat calculate. No, I'm a moron. This is terrible. 0. Okay, I made a boo-boo there. Okay, vars, y bars, function y1. I know there is a 83 or an 83 plus out there. Okay, I know that for a fact. Okay, and then what that does is it gets it in the widescreen, overwrites the previous one. There it is. This isn't going to be valid anymore. Clear. And then this graph. Well, let's look at that window. It's right here. 1 to 13. So negative 10 doesn't really make sense. I always go like see the y-axis though. And then we may have future questions that we ask up to 20 hours. I don't know. I didn't look yet. I did do this last hour, but you know what? We only have to go up to like 150. I just want to be able to see the y-intercept and then the graph. There we go. Nice little picture there. Okay. And then it's the same old, same old. So you write that model down. After 15 hours, how much will be stored? How much caffeine will we have? Well, window. Yes, okay, I have 15 in my window. Trace. 15 forced. Press enter. I don't have to find that value button anymore. I only have 13 milligrams after 15 hours. How long will it take before the caffeine level is 5 milligrams? That is your Y. So Y2 equals 5. Same thing as that last one. This may not cross. Ooh, I don't know if that's crossing there. So I might not have an intersection. All I have to do is say this is going to happen a little bit later. So 25, that looks like a cross. Second, calculate, intersect 5, enter, enter, enter. Okay, we do have an intersection. So it is at 20.9 hours. And then you can do the same thing for 1 milligram. But you'd probably have to extend out your graph. Okay, all good? Everyone fine? Okay, so it's really not going to be that bad stuff there. I don't know what I did there. Did I just close my notes? Okay, so I didn't write anything. Now this one I do have to write. What time is it right now? Oh, 47. Okay, so I do have to get going here. Move my board, and now we're done with the graphing calculator. Okay, this is one where it is not. There's no data. There's no data values to do a regression. But depreciates. Your car depreciates. So you buy a car. Hey, this is what I was telling you, by the way. You want to buy a house because usually they appreciate. If you buy a really expensive car, you're going to lose a lot of money. All right? As soon as you drive it off the lot, if you drive it off the lot, turn around and pull back in and say, I don't want this anymore, they'll say, okay, we'll give you $35,000 for it. What? I just paid $39,000. I mean, they'll instantly start depreciating that thing because it's used now. It's kind of a weird thing, but it is true. If it loses 17%, then how much does it retain? That makes sense? Like how much of the value do you keep? If you lose 17, you keep 83%. That's your B. You got to figure that out. So you're going to retain 83% of your value per year, which is T, and then your initial value or what you spent on it was 39,645. So there's your V of T formula. All right. And that models the value of the Mini Cooper T years after it was purchased. Now, this is a way of expressing this in a different format. Expressing this in terms of what would happen monthly, but it's an equivalent expression. So let V of M equal A raised to the K or times K raised to the M, and it be an equivalent expression where M is the number of months since purchase. So find the value of K. We actually did have this with the A Bers. This was literally today. It's weird that we're crossing paths. So you still at 39,645. And then how many months are there in a year? 12. Okay, so what ends up happening here is we got two things going on. I got to put an M in here so when we plug in months that this actually works out. So I can put this in a bunch of different ways here. So it's the 0.83. And then we're going to raise this to M over 12. And then that to the 12th as well out here. So first of all, what would happen if you multiply these two exponents? Okay, what would happen? What would we end up with? M. All right, but then when I put in months, this is what would happen. You'd have 1/12 of 83% being knocked off of this situation here. So this is mathematically equivalent to this, but now we put this in terms of what happens monthly and not yearly. Okay, so that is what's true there. The domain in years was from 0 to 5 years, but now that I have this in months, how many months are there in 5 years? 60. So now it's 0 to 60. I don't know if that was equal, but for sure that's what's happening. Now, unfortunately, we only have 4 minutes. I was going to have you look at this, but I spent longer on the exponential and depreciation thing of a house. I was going to go through this example, but we ran out of time. So what I will do is just show what the answer is for this, but really what it's not a big deal. And a lot of my A, Bers just left this blank because A, it's reading. B, they got lost in the shuffle. They got lost on what does this mean? What are they asking? And this is what AP questions are like. So I'm going to go ahead and go to this real quick. Boink, boink. Should be right on it. Good. And this is all it is. All right. And last hour we got to go through this and many got it right. So they just say a linear function passes through these points and an exponential function passes through this points. And I had people draw it. They actually drew it out to try to make sense out of it. They drew in a linear passing the points, then they drew the exponential, and then they thought, okay, how do I find these equations? And most everyone last hour was able to get the equation of the line. And then hopefully we can see this here, that I'll have this board here, that I'm getting the other pen. Okay, so number one, what does a line have? Slow. So you find the slope. Oh, and then by the way, that's the y intercept. So if you just read the question, yes, I can find an equation of line from 2 points. Then I read the question continually, and it says an exponential function in the form a times b raised to the x passes through those 2 points. Okay, exponentials look like this. This is actually the initial point because it's 0, comma. I'm allowed to do that because there's no up-down shift like the very first example of the day. Then input, say it. Then input 1 and I'll put 8 into the function to find b. And therefore we get b equals 2, that we can see this. So here is that function. Okay, e to the x equals 4 times 2 raised to the x. Now they ask this crazy thing. The function f is given as exponential minus linear. Okay, whatever. I'll just do that. Sorry, get that up. Exponential minus linear. And that's how it has to be subtracted because you're subtracting the whole linear function. It requires those parentheses. Now what? What is the minimum? Well, how do I find minimums? I go to the calculator and I type that expression exactly as is and I find the minimum. So all you had to do is read it. Every single thing that was in there is everything you know how to do. It was just three things. And that's why some people shut down because they don't want to read the question and try to figure it out. All right. So anyway, that is a true story. I wish I gave you time to investigate that instead of me just shoving it in your face kind of thing, but we ran out of time.